Imagine peering into the atmosphere of a failed star, colder than a desert night, and discovering a gas that no one has ever detected in space before. That's exactly what astronomers just did. And the discovery is rewriting what we know about how clouds form on giant planets and brown dwarfs. Let's start with the target. The James Webb Space Telescope was aimed at a peculiar object that astronomers discovered by chance in 2020 and called the accident. Officially titled YSPA J153429754303. Let's just call it W1534 for short. It's a brown dwarf, an object too big to be a planet but too small to sustain nuclear fusion like a star. What makes W1534 so special is its age and composition. It formed in the early Milky Way, over 10 billion years ago, and it has almost no heavy elements, what astronomers call low metallicity. Think of it as a time capsule of our galaxy's earliest days, a fossil star adrift in the dark. When scientists analyzed Webb's infrared data, they spotted something unprecedented: the spectral fingerprint of Silane, or SiH₄. This is the first time Silane gas has ever been detected beyond Earth. Why is that a big deal? For decades, models of gas giant planets and brown dwarfs predicted that Silane should appear in their atmospheres under certain conditions, particularly in cold, oxygen-poor environments. But until now, nobody had ever found it. On planets like Jupiter or Saturn, oxygen bonds with silicon to make rock-forming minerals instead, leaving no silane behind. Here, on W1534, we finally see it, a perfect match to the theory. This is more than just a chemistry footnote. Detecting silane helps solve a mystery: how clouds form in giant planetary atmospheres. Clouds on brown dwarfs and exoplanets aren't like the water clouds we know on Earth. They're often made of exotic compounds, silicates, metals, even salts. Silane is thought to be a crucial ingredient in creating silicate clouds, which dominate the weather patterns of these worlds. By confirming silane in a real atmosphere, scientists now have direct evidence to refine models of cloud formation, atmospheric circulation, and even how light escapes from these alien worlds. It's a rare case where theory and observation finally meet. W1534 is just one object, but it's also a proof of concept. If JWST can detect silane here, it could find it in other brown dwarfs and maybe even in exoplanets orbiting distant stars. That means we could soon be mapping the weather chemistry of alien worlds with unprecedented detail. And there's another twist. Because W1534 is so old and so metal-poor, it tells us what early planetary systems might have looked like. In a way, it's a laboratory for understanding not just what's out there today, but what was happening billions of years ago, when the galaxy itself was young. So what started as a faint infrared signal has turned into a breakthrough, the first detection of silane in space, proof of long-predicted chemistry, and a new clue to how clouds form in alien skies. What do you think this means for the search for habitable worlds? Could these exotic clouds one day help us identify planets with the right conditions for life? If you enjoyed this dive into cutting-edge space science, make sure to like the video, share your thoughts with us, and subscribe to Add Beyond Earth Buckle Up, and stay tuned for more stories from the frontiers of exploration.